All right, so we're continuing on. You're going to notice it's going to get really hairy. So that's the reason why I'm splitting this up into two parts. So we're going to rewrite trig expressions and get it completely simplified. I will work on getting it into sine and cosine, but I want to use the identity first. I don't want to take the time to let you know to refer back to writing out what the Pythagorean identities and the reciprocal identities are. So I'm wanting you to be able to look at that. I will highlight here that this is an identity, and you can go ahead and refer back to it, and you know that 1 plus cotangent squared theta is equal to cosecant squared theta. So we're going to use that identity, and I'm just going to go ahead and just substitute it. So we have, or I shouldn't say theta, it's alpha. So tangent alpha times 1 plus cotangent squared alpha. Now, just a side note, if you do decide to go ahead and distribute, again, you're going to end up with the same answer. So however you tackle it, you're going to be fine with it. All right, so now I'm going to go ahead and use the identity. So we have cosecant squared alpha over cotangent alpha. All right, it's going to get hairy. So what we end up having to do is we're going to start putting in our identities in terms of sine and cosine. So we have that tangent is going to be sine over cosine. Nope, I'm going another way. What I'm going to do is, I know that if I was to rewrite this, do the copy dot flop, if I've got tangent alpha times, let's see, I'm just going to go ahead and keep it this way because I don't want to throw too many steps all at the same time, times copy dot flop, it's not letting me do a dot, so it's going to be 1 over cotangent alpha. Well, this is a reciprocal identity. 1 over cotangent alpha is going to be tangent. So I'm wondering if I ought to write this one out. So just on a side note, I'm just going to probably have it up here and then erase it because I need all the room I need. So if I have 1 over cotangent alpha, that actually equals tangent alpha. So I'm going to be using that. So then I have tangent alpha times cosecant squared alpha times, and instead of 1 over cotangent, I'm going to put tangent alpha. All right. So now we can go ahead and let's see, how are we going to tackle this? We're going to go ahead and multiply the tangent alphas to get tangent squared alpha times cosecant squared alpha. And then get it in terms of sine and cosine. So we have sine squared alpha over cosine squared alpha times, and then my cosecant is 1 over sine, so it's going to be 1 over sine squared alpha. Right? And so you'll see that the sine squareds, alphas cancel, and then we have 1 over cosine squared alpha. And if you leave it like this, that's okay. If you put it secant squared alpha, I'm okay with that because that's telling me that you do understand the reciprocal identities. It's going to continue to get hairy. So rewrite each of the following trig expressions in terms of a single trig ratio. And so right off the bat on this secant theta times cosecant theta minus tangent theta, I'm going to, my game plan here is to get it in terms of sine and cosine. So I know that my secant theta is going to be 1 over cosine theta times cosecant theta is going to be 1 over sine theta minus tangent theta is going to be sine theta over cosine theta. Now I have it all in terms of sine and cosine. And so if I was to simplify this even more, it's cosine theta times sine theta minus sine theta over cosine theta. Okay, so again, the trick is sometimes we tend to think that we could go ahead and, excuse me, we can go ahead and cancel out the sine thetas. We cannot. Don't you dare do it. It's as bad as killing puppies. That's just like saying that if I have 1/2 minus 2/3 and I cancel those out, you can't do that. Okay? So one thing that you got to be careful with, and this is kind of a review here, is, I wonder if it'll let me do that. Yeah, let me undo it. Woohoo! So if we were to do this and we want to try to have the same denominator, then on this side you would end up multiplying by 3 on this side. And on this side you would end up multiplying by 2 in order to get the same denominator. So that's the same game plan as what we're doing right here. We don't need to worry about it as much, do it as exhaustively, because here on this side we have in the denominator cosine theta times sine theta. Well, we already have cosine theta right here. So what we need to do is we just need to multiply on this side sine theta, this side sine theta. And so in turn we would end up having the same denominator. So it'll be 1 minus sine squared theta. And then I'm going to go ahead and write it as 1. So then it would be 1 minus sine squared theta is over cosine theta times sine theta. And then we would have 1 minus sine squared theta is a Pythagorean identity, which is cosine squared theta. So 1 over cosine squared theta over all of this. All right. And this in turn cancels the only one of them. So then we would end up having something along the lines of cosine theta over sine theta. Well, that is cotangent. So we have it all the way down to one single trig ratio. All right, let's go ahead and let's look at this next one. So here, secant x over cosecant x, 1 plus tangent x. And so on this one, I'm going to go ahead and write it in terms of sine and cosine. Oops. Secant x is 1 over cosine x. Plus, and then cosecant x is going to be 1 over sine x. Okay, it's going to get hairy, don't panic. And so this is 1 plus, and this is tangent x, which I'm going to go ahead and get it in terms of sine and cosine. All right? And so I want to go ahead and get all of these in with the same denominator. So in the numerator, I want a single fraction here, and I want a single fraction here. So that's what the goal is going to be here. So in the denominator, let's see, I'm going to use, so here I'm going to be multiplying. Let me see if there's enough room. I've got to have here the denominator of cosine x times sine x. So on this side, I'm abbreviating, I know. It's going to be sine x here that I'm going to be multiplying. And here I'm going to be multiplying cosine x. And then what's going to be in the denominator up here is cosine x sine x. All right? So on this one, in the denominator, if I put this over 1, well, I have cosine right here. So I've got to multiply cosine here and cosine here. I know I'm not using the x. The whole point is for you to see what needs to be done to get the same denominator. Okay? And so now we have sine x plus, yes, I had to pause. My puppies were protecting me. I feel so protected with a 10-pound and a 15-pound puppies. Yeah, I'm protected. All right, let's go on. So we have sine x plus cosine x, and we're going to write it all over one fraction, which is cosine x times sine x. All right, then now let's look at the denominator. So I'm going to put a big line right here because that's our big line for numerator denominator. So now we've got cosine x plus sine x all over cosine x. Now we're going to do the copy dot flop. Okay, so I'm going to copy what's in the numerator. So maybe if I use a different color. So sine x plus cosine x all over cosine x sine x. That's copy. Dot, which I have a hard time with this program, or yeah, this particular program, flop. So I'm taking this down here and I'm flopping it. Copy dot flop. So then it becomes cosine x over cosine x plus sine x. Always like it that we can see what we can cancel. So remember your invisible parentheses on fractions. I have sine x plus cosine x on the left side in the numerator, and I have cosine x plus sine x in the denominator. So those can cancel because I'm multiplying. If this was addition, then I wouldn't be able to do what I'm about ready to do. But this is multiplying. If I have cosine x plus sine x in the denominator and sine x plus cosine x in the numerator, I can cancel those. So now it's going to look a little bit easier to look at. So now I have cosine x over cosine x sine x. And the good news is I can cancel even more. I can cancel this and this. So then it would equal 1 over sine x. Well, 1 over sine x is cosecant x, and that is our single trig ratio. Okay, so on this one, right off the bat, I want to get it into one single fraction. So I'm going to have the common denominator of sine x times cosecant x. So on this side, I'm going to multiply cosecant here, this side cosecant, and then on this side, it's going to be sine, and this side is going to be sine. And so that way, what I'll have in the denominator is cosecant x times sine x. So let's go ahead and let's do that. So we have cosecant x times secant x minus secant x times sine x. And then this is over cosecant x times sine x. Now, if I was to go ahead and change this to an identity of 1 over sine x, I'm just going to do it right here because of space. So I would put 1 over sine x. Then these would cancel. And so anything over 1, that's what it is 1. So now I have cosecant x times secant x minus secant x times sine x. I could put it over 1, but I don't want to do that because then it gets, it's a waste of paper. Anything over 1 is just whatever it is on the numerator. So now I'm going to go ahead and use the identities where I would have cosecant x is 1 over sine x times secant x is 1 over cosine x minus 1 over cosine x times sine x. And then you do the same thing with getting the same denominator on this one. So then I would end up multiplying sine x here. I'm just kind of abbreviating because I don't want to be worrying about all of this. I'm using up all the space. So now I've got 1 minus sine squared x over sine x cosine x. So remember the identity where we have cosine squared x equals 1 minus sine squared x. So then this would end up being cosine squared x over sine x cosine x. So you'll see what we can cancel. So then this becomes cosine x over sine x, which in turn is cotangent x. This is the last one. I was kind of hoping that maybe you guys would go ahead and try this on your own and see how you do. So I went ahead and did most of it. On this part right here, what I did was I used the trig identity of secant. So secant theta actually equals 1 over cosine theta. So I did all the identities with this, okay? And so on the left-hand side, I did the fractions, because what happens is that if we were to go ahead and get the single fraction, this would be over 1, and so we would be multiplying cosine here and cosine here, and the same thing with here and here. All right, and so that's what I did with this step right here, was I got it in as a single fraction. And so once we got that done, then I continued on the left hand side here and did my copy dot flop. And so right here is the copy right here, and then dot flop. And so if you notice, then we know that these cancel. And so if they cancel, then we can go ahead and write it up here in the upper right hand corner right here. All right, and so now we have cosine theta plus 1 over 1 minus cosine theta, and then I just copied this part right here and I put it over here, which it makes it exactly the same way. All right, so the next step, I had to get the common denominator. And so if we've got 1 minus cosine theta and then cosine theta minus 1, those are not equal. And so what ends up happening is that we end up writing what's equivalent, okay? So in other words, if I was to write this again, then this would be negative cosine theta minus 1, okay? These are all equivalent. These are all equivalent, and it's very important that you understand that, which in turn, that's what we wanted. We wanted to have the same denominator. So now we have cosine theta minus 1. So if I was to go ahead and put that negative here, I ended up putting the negative in the numerator. And so now I have negative times the quantity cosine theta plus 1, and then plus 1 plus cosine theta, and it's all over cosine theta minus 1. So as you can tell, what's happening is that if I've got negative cosine theta and positive cosine theta, that equals 0. If I've got negative 1 plus 1, that equals 0 as well. So now we have 0 over cosine theta minus 1. Well, anything with the 0 in the numerator equals 0. Okay, so that concludes our video, and this is the assignment that you will be working on. And just let me know. You have ways to contact me if you need any help. Good luck.